Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Identify the hybridization and position of each hydrogen. Looking at the cyclohexene ring with one double bond at the top. H_B is on the carbon situated between the two allylic carbons, i.e., the bisallylic, doubly allylic position. This carbon is flanked on both sides by carbons that are part of or adjacent to the double bond system. H_C is on the carbon directly adjacent to the sp2 carbon of the double bond on the right side, allylic position, one allylic carbon. H_A is on the carbon on the left side, also allylic but further from any additional stabilization. Moving on to the next step. Assess acidity based on stability of the conjugate base, carbanion. Acidity correlates with the stability of the conjugate base after deprotonation. Greater delocalization is equal to more stable carbanion is equal to more acidic CH, H_B, bisallylic position removing H_B gives a carbanion that can delocalize into both double bond lobes, to the left allylic carbon and to the right allylic carbon through the pi system, giving the greatest resonance stabilization. This makes H_B the most acidic. H_C, allylic, right side, adjacent to the double bond removing H_C gives an allylic carbanion stabilized by one set of resonance structures with the adjacent double bond. Additionally, from the structure, H_C appears to be on the carbon more directly conjugated or in a position with slightly better orbital overlap, making it more acidic than H_A. H_A, allylic, left side also allylic, but with slightly less stabilization than H_C due to its position relative to the double bond geometry in the ring. It is the least acidic of the three. Moving on to the next step. Most acidic, H_B, bisallylic, maximum resonance stabilization. Second, H_C, allylic, good resonance stabilization. Least acidic, H_A, allylic but least stabilized. This gives the order BCA. And for the final step, ABC, incorrect, places H_A first, which is least acidic. BAC, incorrect, H_A should not be more acidic than H_C. BCA, correct, matches our analysis. DACB, incorrect, H_B should be most acidic. Therefore, the correct answer is C. Therefore, the correct answer is option C.